live! Hi, I'm Tim Van Milligan, and this is RockSim Live. Thanks for being with us today. Today we're going to talk about RockSim software, the RockSim Pro software, or the Launch Visualizer. Your choice. This is run live, and we are taking your questions live. So if you have them, go ahead and put them into the chat, and we will try to get to them. We've already got a whole bunch of people here. We got Terry Wheelock and Rosa from Ottawa. And there's a whole bunch of people that haven't checked in yet, but I know they're watching. So again, welcome to the episode. Let's see, where do we get started here? Do you like my new poster? Keep calm and fly rockets. I was at the World Space Modeling Championships, and the team from Great Britain gave me a little sticker like that, and I said, "Oh, this is great. I got to make a poster out of it." So I made one up and threw it on the wall, and yeah, keep calm, fly rockets. I do have a couple of questions that came in via email. Carlos sent in one, and we'll get it from Carlos, and he says it's muggy in Marietta, Georgia today. I got a monitor over here that I'm checking. And then I got another one from Greg. So we'll get to both of those today, but first let me bring up my screen here. There we go. So if you are brand new to this and trying to figure out what RockSim is and how do you get involved with it, how do you get started, you come to the Apogee website. Our web address is apogeerockets.com, and then we have this scrolling banner bar here, and it has the Launch Visualizer, which is at rocksim.com. That's our online version. The difference between the online version and the desktop version is with the online version, you can only simulate rockets. You can't design them. With the desktop version, you can design. But when you're out on the launch field and you don't have your computer with you, but you do have your cell phone, rocksim.com can allow you to run those simulations really quick and find out what motors to use when you're on the launch field. There's a bar here for RockSim, and if you click on that, it will take you to where you can download a free trial. You can learn more information about it. What we're doing today is RockSim Live, and if you're on the home page, this is the free RockSim training. That's what we're doing right now. And if you click on this little image, this will take you to our archive, where we archive every episode that we have done. We are doing episode number 130 today. It is July 21, and we'll have it here next week's. But here's what we talked about last week. Basically, upscaling a kit in RockSim. We talked about that. We talked about 3D printing parts from RockSim. And if you want to find something in RockSim, that we've talked about, just come to this page and do a Command F, which is a find, or on the Macintosh it's Command F. On the Windows it's Control F, and it brings up this finder box up here, and you can you can do clusters, and it will find all the times that we talked about clusters, and then you can scroll through them, and it will highlight it on the page. And you can find the time in the video, and there's the YouTube link right there, so you can find the timestamp, and you can go right to that specific topic. That I use all the time. People ask us, how do you find things? And that's what we do. You can use this on any page of the Apogee website, any website, in fact. For example, if you go to the how-to and guides, come down here to the Peak of Flight newsletter, come over here to all the newsletters. And again, this is our archive, and we've had, 604 newsletters. And again, the same thing, you do the find with the Command F or Control F on your keyboard, and you can type in what you're looking for, and it will look through the newsletters, and it will find every time that word was talked about. This is great for finding things. But we're here to talk about RockSim. So again, on our website, go to the how-to and guides, come down here to software, and here's the free trial you can download. You can purchase it. What is RockSim? The features, the frequently asked questions, the system requirement, the version history. There's so much information on our website, as you know. We try to make things as easy as we can to find. Yeah, so I'm checking this over here, seeing if there's any new questions that came in. We have Johan, and I know Johan is from the Netherlands. So welcome, Johan. It is like 10:05 p.m. in the Netherlands, so he's watching late at night. So he's probably trying to be put to sleep with the tone of my voice. You are now in a trance. I'm going to keep you awake. Okay, so RockSim. So our first question, let's see if I can bring that up, and that was from Carlos, and he says, I appreciate your description of how and why the launch visualizer has a nose tip view of the terrain below, since I am making a modernized Estes Cinerock with a camera port, essentially where the Cinerock's movie camera lens was. Imagine a launch visualizer pod, which was imagined to be made of clear material that is taped to the side, sort of like a single chopstick sticking out forward well past the nose cone. Would that reorient the view to be based on the new most forward point of the rocket and get that nose cone to stop blocking the view so much? Okay, I understand what he means. So let me bring up the launch visualizer. I'll bring up a new window here. So you go to rocksim.com, and this will load it onto my screen. Let me resize this for you a little bit. It's loading. And if I go to login, and I need to log in, because when you log in, you can log in for free, and what that gives you is additional options that if you don't log in, you don't have. And some of those things are you can launch bigger rocket motors, and you can save designs, and that's really what it's about, is so you can save your own designs, because we have to allocate space on our servers for your design. So that's why we would need you to log in. But if on my account, I have dozens and dozens of rockets already pre-saved. So let's just grab one here. Let's take this one right here. It's an Exterminator. And as soon as I load it, it will redraw it right here. And this is a 3D view where you can rotate it around. This blue arrow here is the direction of the wind. So the wind is coming from the west. There's a compass on the ground. Because that's important when you launch a rocket. You need to know where the wind's coming from. Let's choose a different launch site so that we have something that has a lot of terrain in the background, and it's got to load the image here. And I'm going to go to a 2D view, so I'm looking straight down on the rocket. Right here is a compass. The black arrow points to the north. I'm in Colorado here. Let's go to Colorado Springs and zoom in. Here's the Air Force Academy, if you've ever been there. Here's the cadet area right here. They got this beautiful field up there. It makes a nice launch field. So let's say I want to launch right here. And you can see there's soccer fields there. So that's where my launch pad's going to be. And to confirm that that's where I want to launch, I hit confirm the launch site. And what it does is it grabs the latitude, longitude, and the elevation above sea level, and it just pre-populates it. So now I know I have a wind coming from the west, which I can live with. There's a baseball field here, and a football field here, and a track field up there. They have a lot of athletic fields there at the academy. Okay, so let's put a motor into this rocket. So I'm just going to put one in real quick, and I'll just choose the first thing that I can find. Click OK, and let's launch this rocket. And it's going to use 71 points, and I got a lot of points available, so I don't really care. And it launches. It's running the simulation. So here's the rocket sitting on the pad, and it's still loading the background. All right, so now we're seeing the Air Force Academy right there in our launch field. And so what we have is different views, and what Carlos was talking about was the camera view right here. And when you look at this camera view, you know, the nose is in the way, you know, particularly when we launch. So if we launch this thing, the rocket takes off, and I'm going to pause it right there. And the nose is kind of blocking the view. Let me turn off the smoke. Where a lot of the background is being obscured by the smoke and the flames. Let's turn that off. Click OK. So now we see we got this rocket right here, and there is terrain in the background. And as the rocket goes higher, we see more terrain. But the problem is the rocket is obscuring the view. And what Carlos was saying in his email is, if I put, you know, something pointy on this rocket and extend it really far forward, can I make this rocket image smaller so that I can see more of the background in the view? I have never tried that. Carlos, why haven't you tried it? So let's open up a rocket. And see if we can do that there. So I'm going to my desktop, and my computer's acting a little bit slow because I'm trying to do too much here. Okay, so here's that exterminator rocket that we were just looking at. So I'm going to open that up. All right. Okay, so there's the rocket, and what we're going to do is we're going to put a stick extending out the front end, because in the launch visualizer, the image, it first calculates the length of the rocket, and then it takes the camera and it moves it a little bit forward, a little bit, and then just a little bit off the center line. And so what if we put if we extend a stick out the nose cone and make the rocket longer, what we're hoping is that we move the camera will have to move further away from the rocket as well. So that's what we're going to try. So how do we do that in RockSim? So we have our rocket, and we're going to go to the rocket design components, click on that, and we have this nose cone. And what I'm going to do is I'm going to put a body tube in front of the nose cone. So normally you'd start your rocket at the nose cone, but if you click one component up to the sustainer, then I can put a body tube there. And so I'm going to click on that body tube. And I'm going to choose a skinny one. Well, I'll just cancel out of this. I'm going to create my own dimensions here. And let's make the outside diameter, 0.25 inches. And the inside diameter, we'll make it solid, so it doesn't have an inside diameter, but we'll make the length 20 inches. And it put it behind the nose cone. I wanted to put it in front of the nose cone. See what it did there? Let's go look at it in 2D. Ha! See, in 2D it shows it there, but in 3D it shows it there. That's interesting, but it kind of like moved the nose cone from used to be right there to right there. That's interesting. Why did it do that? I'm going to click OK. All right. So at this point, I'm going to save the design, and I'm going to do a file save as. And I'm going to put it on my desktop because I'm going to take this design and then upload it into the launch visualizer. So what's those fish called that have the long point? A warnail? Narwhal? Narwhal? Let me look that up. Yeah, I was right, a narwhal. Doesn't have an E on the end of it, though. So that's what we're doing here. We're making the narwhal. Okay, here's my narwhal rocket, and I've saved it. And now in the launch visualizer, you go back over here to select rocket, click on that, and I'm going to upload a new rocket design. So basically, I'm taking it from my computer and uploading it into the cloud and storing it in my database. So to upload it, you click the Browse button, go to the desktop where I saved it. There it is, narwhal with an E on the end. And then upload. Upload. Let's see what it looks like when it uploads. See if it moves the nose cone here. Still loading. It did. It moved the nose cone up there. That's interesting. Well, let's give it a try. So let's load a motor, choose an engine. Doesn't matter what the delay is. Click OK and launch. Simulate. Let's see what happens. I'm looking at while that's loading. Let's change this view to the camera view. Well, look at that. That's a weird camera view because now we're looking through the camera. Why is this? Something went wrong with this launch because it's going to stay in the air for 3,600 seconds. Let's go to a regular view and see what's going on there. In fact, let's go to this view. So somewhere like right in here is the rocket. And let's turn the smoke back on so we can see where the rocket is. Launch. Rocket took off. And then all of a sudden it disappeared. And it says our altitude is 0 feet. Oh, this is strange. Well, let's try it again. Let's go back to our RockSim file. Let's start a new rocket from scratch. Let's see if that's going to make a difference. So, save changes? No. Okay, so I'm going to start my rocket with a body tube. And this body tube is going to be, I'm going to cancel that there. Again, I'm going to use the 0.25 inches. So it's a 1/4 inch stick, 20 inches long. and made out of paper, and the color of this is white. Click OK. So now once we have a body tube, we cannot install a nose cone. That might be the reason why. But we can do a transition and make it look like a nose cone. So let's do I'm just going to grab this because I want BT80. See, there's my transition. So the shoulders have to go, so at least the front one. So click on the shoulder tab and then clear the front shoulder values, and that goes away. The rear one, let's change the length. That looks pretty long. Let's just make it 2 inches long instead of 2.25. And then let's change the shape so this looks like a nose cone. So we can do that. Let's change it to an elliptical. And then the front diameter is 0.25s, and then it will match. How's the rear diameter? 2 point. What diameter do I want? 2.6 is a BT80. The front diameter 0.25. Okay, so there is that. I just want to make it a little bit longer. Just kind of recreate what I had before. My narwhal. Let's make it out of balsa, and we'll make it solid. 48 grams. That sounds reasonable. Color. Let's make it red so we can see it. So in 3D, it's going to be red. Like that. Okay. And then let's put on a body tube. And we know it BT80. That's 66 millimeter. And let's make that longer. And we'll call it a motor mount. And then let's put some fins on here. So let's put some fins on here. We'll cancel out of there. And RockSim will just draw some generic ones. And I'm going to leave those okay. And let's throw in a parachute just to make sure that we have something that's coming out. Parachute. And we'll make it a 24-inch nylon. Let's see where it's located. So it's right there on the shoulder, so we just have to move it back a little bit. And let's click OK. And let's save this onto our desktop, and we'll call it the narwhal. We'll take the E off the end. Version 2, click Save. Now let's, okay, so we saved it to the desktop. Let's go back to the launch visualizer. I got no power. Somehow, I forgot to plug in my power cord on my computer. I just noticed my battery was going down. Okay. Okay, so let's go back here. We're going to upload this new design. Narwhal version 2, click open, upload. The rocket's going to look a little bit different, but it's going to be fairly similar in shape. Okay, so there we have. So now we have the stick coming out the top. That's what we wanted. So hopefully, when we run the simulation, it will see that there's this stick here and put the camera out here. So let's select the motor, choose an engine. I'm going to choose the diameter rockets that are smaller, and choose, I think we chose like an F44, that's fine. 8-second delay, and okay. And let's launch it. The launch button is here underneath my face, if you can't see it. Okay. This rocket didn't go very high. So what happened there? Let's see what's going on here. Let's go here to flight events. And maximum ejection delay. So select our motor. Ejection delay 8 seconds. Why did this thing not go high? That F-44 should have burned for like a second at least. Maximum altitude of only 22 feet. Why? In the simulation when the rocket returns to the ground, why didn't it take off? Let's try that again. Let's maybe choose a different motor. This is what we do. We just play around until things start making sense. Sort those by diameter. 24, 29, F25, 6. Click OK. See, this burns for 2.69 seconds. If we launch it, simulate it, we should be a lot longer than 0.38 seconds for our simulation. See, this one's going to go almost 3,600. This one stays in the air an hour too. What the heck is going on? And this one only goes 45 feet. Let me go back to RockSim. See, my center of gravity is here, my center of pressure is here. Let's put in a rocket motor. Maybe this rocket's going unstable or something. Choose an engine. And let's see, diameter, we had that. That was a 29 millimeter F-22. Let's go 7 seconds. 0.5. Click OK. Click OK there. It's still stable there. Let's run it in RockSim and see what RockSim thinks. Flight profile. Yeah, see, that's more normal. 1,300 feet. Yeah, it went a little crazy somewhere in there in the middle. I'm trying to think, why would that go crazy here? Let's save this again. Close that. Where's my desktop? Desktop. Let's call it version 3. I'm going to open it in RockSim Pro. RockSim Pro has the launch visualizer built into it, so we can open up the design, run it in RockSim Pro, and see if it does the same thing in RockSim Pro as the launch visualizer. Okay, so you can see RockSim Pro looks a lot like RockSim, so it's not too much different. Let's open up that design. It's running a little slow. Desktop. Version 3, open. Okay, that flight simulation that we just ran, let's edit that. 2J, flight events, launch this is going to be in San Diego. And flight profile, let's see what this one does. This one in RockSim Pro, it only went 700 feet. It might not like that little stick sticking out the front end. But we might be able to try something. I got an idea if this doesn't work. So it's got to reload the maps. It's got to reload our background. Okay, so to kind of get your perspective, we're on this little island here in the middle of San Diego. North, let me spin this around so north is at the top of the screen. So that's the island in the harbor. And SeaWorld is right here. And where'd our rocket go? Okay, so let's go to the camera view. It kind of sort of worked. We're still seeing a lot of rocket right there. We're not moving the camera off to the side. It worked a little bit, I would say. Let's stop the animation and let's try my trick that I wanted to do. Okay, so here's what we're going to do is we're going to put a nose cone on the tip of this. So we're going to go back to the rocket design components, and under sustainer we're going to add a nose cone, and it's just going to be a little tiny nose cone. Let me cancel out of that. The outside diameter is going to be 0.25 inches because that will match that dowel, and we can barely see, can't see it yet. So there's our nose cone right there. Okay. This nose cone weighs 0.5 grams, so it doesn't have a lot of weight. So it shouldn't affect the flight much. And we should probably have done that with the, this dowel to make sure that its weight doesn't affect the flight. So this is our dowel. Let me open it up. I'm going to call it dowel right here. And instead of being 20 inches, let's make it at 60 inches. So we're going to make it a lot longer. And it says this weighs 54 grams. So let's make it out of balsa. Or let's just change the thickness, 0.249. So basically I made it hollow, and now I got it up down to a gram. So now it's not hardly any weight. Click OK. And our center of gravity is still here. The center pressure is right there. That looks fine. It's an odd looking rocket. Let's launch it again. And yeah, flight profile. I'll go right to the flight profile. I'm not going to change anything. Same motor, same everything. Okay, so there's the rocket sitting on the pad. It looks like a launch rod sticking up, but that is actually that nose. And let's See, this is only going 0.74 seconds. So why is that? So we're looking down on the rocket, and now we're looking down from 60 inches in front of it, but we're still seeing a pretty big rocket. But I think it is smaller, because I think before it was like this big. And when we launch it, so we saw the smoke there. The question is, why is it only going that high? I'm mystified, but it kind of sort of worked, but I'm not sure why it's not fully working. Let me go to the questions and see if we got other questions. Johan said that latest Apogee 2-stage rocket design is awesome. He's talking about the TTV rocket. Let me go here. If I move out of the camera view and show this poster, this is the TTV that he's talking about. If I lean too far back, I'm going to break my chair. So that's our newest 2-stage rocket that he's talking about. Carlos said reposition nose cone with sliders. Is he trying? You're trying to say move the nose cone off to the side? The nose cone defines the center line of the rocket, so you can't move the nose cone off to the side. If we tried with a pod, the camera is still going to say, this is the nose cone, no matter if I put a nose cone off here to the side. So we can't do that. Terry says, Tim B. Sneaky Deaky. My chopstick was clear plastic. Yeah, you can make this clear as well in RockSim. So if I go into 3D, give it a second here while it redraws. So right now it's white, but if I open up that part and open up the dowel and go to the color, I'm going to go back here to 3D. And if I go to opacity, see right now the opacity is 1, which means 100% opacity. If I make that 0, it will be clear. See, that's clear. Click OK there. I'd have to do the same thing with the nose cone. And so I'm going to open up the nose cone, go to the color tab, and then down to opacity and make that 0. So my nose cone is out here and now it's clear. Click OK. And so there's the rocket, but if in 2D you'll still see it. See, it's still there. It's just clear in 3D, so it's totally clear. And if we launch it, go back here to the flight profile. The question is, why is it not going high? What's causing it to stop? Terry says the audio has gone rogue. Hopefully that will be better. Terry likes to make rubber super ball nose cones and make trouble bounce recoveries. Can RockSim measure the bounce? The answer is no. Once the rocket hits the ground, it says I'm on the ground. like a dead cat bounce. So why is this stopping? That just has me mystified. Okay, so I do have another question from somebody else, so let me get to that question. Okay, so it was from Greg Sindison. So here in the blue, he says, I have become interested in flying dual G-80 rockets since these are still model rockets below level 1 certification, yet potentially supersonic. Actually, 2G motors is classified as an H motor, and your club would probably say you have to be certified to fly it. But I understand your point. I want to, now you can do a G, 2 Fs or a G and an F. I want to compare staged versus clustered. However, I can't seem to get a model with 2 tandem 29mm tubes to work. I've tried including a very tiny center body to no avail. For stability estimation, I ended up creating a single body with the same cross-sectional area and fudging in a single motor with the mass and thrust curve of 2 separate G motors. I like his ingenuity. So here's my question to Greg, and he's probably not on the episode right now. I don't see his name. When he says tandem 29mm tubes to work, is that a cluster of 2 motor mounts in the same rocket? Or is it like you have a rocket with a body tube, and then you take another rocket, go side by side, and doing it that way? I think Estes used to have a rocket. I forget the name of it. What was it called? Sidekick? Sidewinder. No, it wasn't the Sidewinder. Sidekick. Yeah, that's it, right there. Okay, so if you see that rocket right there, and let's see, it has 2 rockets that are side by side. So when I hear the word tandem, this is what I think of. But you could have a big tube with 2 rocket motors in it, or you could try to do side by side, like this Sidekick rocket. I believe you can do this in RockSim. It's just going to take a little effort. So let's do a 2-engine cluster. So let's start a new design. Save your changes? No. And to start a new design, let's call this a cluster. And it's a single stage, and that'll be fine. And start with a nose cone. And we'll make it a 66mm tube, which is a BT80, so that's 2.6. That's basically what we were just playing with. I'm going to be more diligent about this one. So this one does have a foam nose cone where Alfred Indy says, yeah, Greg sounds like he's upscaling the Estes Sidekick rocket. But Alfred Indy was talking about Terry Wheelock likes to make rubber Super Ball nose cones. So this is a flexible urethane foam nose cone that we make for egg capsules, egg lofters, so that it gives it a little bit of cushion when it bounces. and they do bounce, not very high though, but RockSim does not calculate how high they bounce. Click OK. I'm going to put a body tube on this, and again this was BT80, 66 millimeters. Click OK, and let's make it I don't know, let's make it 36 inches long, make it a longer rocket. And this time I'm not going to make this a motor mount tube. Click OK. We're going to put in let's put some fins on it again like we did before. Just click on the fins button. It looks in the database, and I'm going to cancel out of the database, and it just threw some generic fins on here, and I might just make the fins a little bit smaller just because they looked overly large. Come on, let's go 3 inches. There we go. I like that. And click OK. So now we got a basic rocket. Let's put in a motor mount. So now this is how you make a cluster rocket. So we're going to do a inside tube, and he wanted to use G motors, so that is a 29 millimeter tube, and we'll check that. Ooh, that was a 33. That was bad. So if you don't like the tube that you put in, just go back to the database. Again, choose from the database. I wanted this one because this is a heavy wall tube. I have two 29 millimeters. I got this one right here, 13 inches, or the 34 inches. But if you look at the inside diameter, this one has a larger inside diameter, which means it's a thinner wall tube. This one has a it's not right. This one should have a larger OD than this one. Something's not right. Well, anyway, so there's a tube, but it's too long, so I'm going to shorten it up. I'll go back to the General tab and change the length. 8.125, and we're going to measure that from the base of the rocket, and then I'm going to put it at 0 inches. So now it's going to be right here flush with the back end of the rocket. If I look at the back of the rocket from the rear view, there it is right there. I say this is a motor mount. And I'll click OK. All right, so now we're going to put in some, so we're going to do a cluster. So to do a cluster, first you highlight that tube, and that should be, let me change the name of that motor mount tube. Okay, let's color is this red, that's fine. Okay, so now with that highlighted, now the cluster button here highlights, so click that, and then it's going to go through the cluster wizard process, and then just click continue here, and you can select the configuration. So if I go side by side, I can get them in. If I try 3, no, they're going to interfere with the wall. The most I can get in is 2. So I'll continue there, and then continue, and say done. So now we have 2 cluster tubes. It looks like there's one, but if we look at it from the top view, you'll see that they are side by side. And if I look at it from the base view, oops, that's 3D. Base view, you can see that, you know, they are side by side. Let's add in some centering rings. So click on the body tube because that's where they're going to be, and come down here to centering ring. Let's add that ring, and we'll just cancel out of the database, and we're going to auto calculate the values. When you do that, it will automatically calculate the inside diameter. And since this is a cluster, there's going to be 2 holes in it. And so let's change the location. Right now it's right here. First we got to give it some thickness. So I'm going to give it 0.125 inches, which is 1/8 of an inch. And then I'm just going to slide it back. And you can see right now it says ID is 0, so there's the hole is 0 inches. But as soon as I slide it over those tubes, you'll see something change. Boom. So now we got 2 holes, and it shows the inside diameter of each hole. And I'm going to move this one to the back. So this is my back centering ring. I'm going to move it a little bit forward. Click right there. I'm going to call it the rear centering ring. Click OK. And I'm going to duplicate that. So I'm just going to highlight it, do a right click with my mouse, do a copy, come up here to body tube, right click and do paste. And you can see I now have 2 rear centering rings, and I need to select one and move it. And I am going to slide it forward. You can see I'm sliding it forward. Okay, I'll leave it right there, click OK, and I'm going to change the name. Now it's the front centering ring. Front. Okay. Let's go side view. It shows 3D. Okay, so there's my 2 tubes in the engine mount. Let's throw a parachute in here. So body tube, then we're going to come down here and find the parachute. And let's do a 24-inch nylon, click OK. Going to put it up here, so we're just going to slide it back here. Okay, so that gives us a rocket. We can put in everything else like engine retainers and the shock cord, but I just want to run this simulation real quick. So we have our rocket. Let's save it. I'm going to save it to the desktop again. And we'll call it the cluster G. Click save. Let's load some rocket motors. Choose engines. It's choosing the Estes engines. Let's choose an Aerotech engine, F25. Let's go 9-second delay, click OK, and it loaded into one of them. To load the other, just hit load all, and it takes that same motor and loads it into both. And let's launch it real quick, and let's see if this one launches. Yeah, that's good. I'm seeing a lot better numbers flying through there. Okay, so we're at 3,200 feet. And now it's going to load the launch visualizer because we're still in RockSim Pro, but RockSim will be the same. And I think we're still in San Diego. So where's the body tube and the nose cone? Well, remember the last time we made a nose cone and a body tube, we changed the opacity to 0. So when we created the new nose cone and the new body tube, their opacity, RockSim remembered that we liked that. So that's why we're not seeing the nose cone and the body tube. But we can launch it. And our rocket's taking off. It's got a clear tube on it and a clear nose cone. It's a ghost rocket. And it's going up and up and up. And let me pause it here. Okay, the parachute just came out. Let me turn this and get a, let me go to a trans side view. So there's our rocket. It went really, really high. So here's the island in the middle of the bay. And I bet you this one might land in the water. Let me bring it all the way down. Sure enough, it landed in the water. So yeah, we would have to do some modifying the trajectory, probably angling it more to the west so that it does. We're on like the narrow the narrow of the island, or we could launch it a little bit more to the south and then have this larger area to land on. Okay, so that is a cluster. So you saw how we did it. It was pretty simple. You know, we just had a rocket and we just added a motor mount to it, and then we just clicked on the cluster button, which was right here, but you have to highlight one of the motors first before a cluster will illuminate. So that is a simple cluster. So now to do a tandem rocket, let's start over. So a brand new design, and you do a nose cone, and this time we're going to do a 29 millimeter rocket. So I'm looking for outside diameter of 29 millimeters, which is like 1.14 inches. So I'm scrolling down. Okay, so here's an Apogee PNC 29, and click OK. So that's going to pull up a nose cone, and let's change the opacity back to 1 so we can see our nose cone in 3D, and we'll change the color to, I don't know, green. Click OK. So we have our nose cone. We're going to add a body tube, 29 millimeter by 34. I wanted to see, yeah, see, this is the thick wall tube. Oh, okay. So we needed we either need to make our nose cone a little bit bigger or the body tube a little bit thinner wall. So this body tube is 1.21 inches. So let's click OK there. Oh, in the body tube, I also need to change the opacity to 1. Let's change the color to blue. Okay, so 1.21. So I'm going to go to the nose cone and just tweak the outside diameter. 1.21. Okay, so when I do that, now the nose cone meets up. You know, it's perfect right there. All right, so now this body tube is a motor mount. So let me say this is a motor mount and say OK. And now let's throw some fins on there. Cancel out of this. And I'm going to make it a 4-fin rocket. Okay. And I want to take those fins. Okay, I'm going to click OK. So if I look at it from the rear view, you know, you can see the 4 fins coming off. What I'm going to do is I'm going to delete 2 of them, because I'm going to do this tandem rocket, I need to have, these fins will interfere if I put another tube off to the side. So I need to delete 2 of them. So how do I delete 2 of them? Well, if you highlight the fin and you come over here to this button called split, and the purpose of this is to split fins as a group into individual fins. So if I click on it, it's going to give me a warning, and it's going to say, you know, you're going to split these fins apart. Are you sure you want to do it? Because once you split them apart, you can't turn them back into a set of fins where they all act as one. So if you move the position of the fin, if you move one, they all move. But once you split them, if you move the position of one fin, the rest of them are going to stay where they were. So I'm going to say yes. So now we have 4 fins. So there's fin number 1, and if I highlight them, you see how they'll highlight down here at the bottom. 3 and 4. So I'm going to delete number 1 and 2. So 1 delete. It's going to ask me, are you sure? And I say yes. Number 2, delete. I say yes. Okay. So now we have a rocket that looks, like this. And what I want to do is to duplicate everything, and we're going to add it to the side. So first I want to do where am I going to attach it? And I think I'm going to attach so that anything off to the side of the rocket other than fins and launch lugs have to be added to the rocket as a pod. So I have to say, where is my pod going to be? So I can attach a pod to a nose cone, or I can attach it to a tube. And it shouldn't matter, but I think I'm going to make it easy on myself, and I'm going to attach it to the nose cone. So I'm going to create a new pod right here, and this is going to be our sidekick. It created a new screen and it added it off to the side. Okay, so I'm going to call this the sidekick. And I'm not going to be able to eject this because I want it to stay with the rocket. And see, right now this pod is right there. And that's okay. So now we're going to attach the part. Actually, I want to cancel this. Save your changes. No. The reason I wanted to cancel it was because I want to copy all these components, and I want to copy them as a group. So if I select the nose cone and I choose copy, now it's copied to the clipboard. And now I'm going to add the pod. I'm going to do the same thing I did before. It keeps putting that on that screen over here. Sidekick pod, ungroup it, click OK. Okay, so now we have this pod, and I'm going to highlight here and then do a paste. And it should take everything that I copied. Oh, it only copied the nose cone. That's okay. It's okay. So we have the start of the rocket. So we have two nose, and if I look at them from the side, they're where they should be. So I'm going to do the same thing with the body tubes. I'm going to do a copy, come up to the nose cone, and paste. And it did paste the fins as well. Let me click on here. Come on, redraw. You see the two fins are in the way, so I need to move my fins on that pod. So this one right here, let's edit that fin. And I'm going to go to a base view so I can see what I'm doing. So there's the fin right now, and I am going to go to the radial position tab. Oh, there was an easier way to do this. Let me cancel out of that. I'm just going to go to the pod right here, edit the pod, and I think I can change the radial position of the entire pod. Let's see what happens if I do that. No. That didn't work. I do have to do the fins one at a time. Okay. Well, actually, I did want to move that off to the side. And I needed to move it off to 45 degrees. Radial position. I'm going to change the radial angle to 45 degrees. See right there. And so then I'm going to take these two and I'm going to rotate them 180 degrees, I believe. So those fins. So that fin right there, and I'm going to rotate it around 180 degrees. So the radial angle is 0. Is that right? I don't know. Let's rotate the next one. See if it looks right. If not, we can adjust. Yeah, that will be right. Radial position, minus 90. And this one will be positive 90. Yeah, that looks right. Okay, so now we have a tandem rocket. We don't have a parachute or streamer in anything, so let's add one. Parachute. 15-inch nylon parachute. And where are we going to put it? Right now it's right here. We're going to slide it back. So only one of our tubes we're going to put the parachute in. You can put a parachute into both tubes and that will be fine. And why did it move that fin over there? It doesn't show it moved there. It shows it moved there. That was weird. Let me see if it's connected to the parachute. No, I can move the parachute because that was the only thing I added. Which fin is that? Fin number 4. From the base of the owning part, it should be at 0. So that one's fine. Fin 4 on that one. This is just weird, man. It doesn't like the math. Because that fin is also 0 inches. There's just something weird going on there. It's just weird. When you start doing weird things, that's when you find all the weird bugs. But this should work. I should be able to launch it. Choose an engine. F-27. Well, he wanted to go G's. G80. We're going to have to go really long delay. 10-second delay. Engine overhang. 0.5 inches. Okay. Let's load all. Flight profile. Must save your design. So it's going to ask me to save it. Tandem. I don't know, tandem. How about increasing the length of the body and add 3 centering rings, 1 at the rear, 1 at the top, and 1 in the order of the body when you complete and delete the body. I'm not sure what and Andy Elford is talking about there. 3D printer guy says, are Cesaroni still producing motors? I heard they had problems on a forum, but I'm not sure if I should take that with a grain of salt. Yeah, you should take that with a grain of salt. We're still getting motors from Cesaroni. They're a little bit slow, but they are still producing. Carlos A says, I want to build an Apogee Aspire with dual deployment. What reliable electronics are available and would you recommend? I would recommend, we sell 2 dual deployment altimeters that are small, so I'd recommend one of those. Then we also have bigger ones, but the one we would recommend are the small ones because you want to put it in a small rocket. They'll all work, and any one of them is no better than the other. So if you can't decide, flip a coin. It should work just fine. People have done it a lot with the why am I not seeing the fins here? Maybe the fins are underground. It's going 213 seconds. Yeah, the fins were underground. Okay, so let me pause it here and rotate it around so we can see, yes, there are 2 tubes there. This is a tandem rocket. I'm giving you vertigo. I'm giving myself vertigo, spinning them around. So that worked. That worked just fine. I just don't know why the fins in the 2D are being drawn odd like that. There's some kind of math error going around with the visual display. Alfred Indy says, can you put that dual rocket file out for download? I would like to use it and try to design the Estes Sidekick. Where would I put it? I'm trying to think where you would be able to download it. Let me save it. Let's go to the launch visualizer. Let me upload it to the internet. There's the tandem. Upload. Click OK. So there's the rocket. See, it's drawing the fins just fine here. We need to run a simulation. So I'm going to take that simulation and rerun it. Click OK. Rerun. Where am I launching from now? Am I still in San Diego? Yes, I am. All right, so look at this. It's going to stay in the air for an hour again. So something's going on. What is going on with my launch visualizer? We might have to restart the server. There might be some kind of error going on. I'll ask Michelle to restart the server. But before we do that, let me share this. Click OK. What did it ask? Share. There's no simulation to share. What do you mean there's no simulation to share? I just ran it. Okay, it wants a new simulation. Where's that G80? Click OK. Load all. Let's see, choose the launch site. It doesn't matter, we'll just choose this one. Click OK. This will be a different launch site than the Air Force Academy. It will be right here. And let's launch it. Simulate. Let's see if this one runs for an hour. No, this one ran just fine. It's loading the background, that's why it's still black. Now it's coasting upwards. Okay, pause this. This is not where I thought I was launching from, because there wasn't any houses there. Let me zoom out. It's still loading the maps. Well, maybe it was. I don't know where my rocket is. Find the rocket. The rocket's right here in the middle. If I zoom back in, you'll find it. There it is. Zoomed in too far. I guess there are some houses around there. Okay, so now let me share this. Share. Come on, share. Okay. Copy, close, and I'm going to put it in the chat. Okay, so that will, if you click on that link that I just put into the chat, you will see the same simulation that I just ran. And that doesn't give you the RockSim file, though. It just gives you the simulation. There's just like no easy way to share the files without uploading it onto the Apogee website. And that takes a little bit of more effort than this just did. I will try to put it up there, and Carlos is still trying to get his camera to work. He says, how about making a working offset narwhal? That's what I was trying to tell you, Carlos, is the camera is always going to be at the nose cone of the rocket. And even though you, in this particular tandem rocket, it's, you know, when you start the design, you pick one of them as the nose cone, as the center line. And so if I look at it from the rear view, come on, button. Button, oh, this button. It's always, one of them is going to be the, I think it's this one right here. So if I launch it, you know, you see this is the center line of the rocket, and the camera's always off of that one. And in this particular case, it kind of put the camera looking down between the two nose cones. So I understand what you're trying to do, but because with this particular camera view, the math involved in coordinating all the geometry is just incredibly, incredibly hard. And this was the only way that we could do it where we could at least get some of the rocket in the view. So this is the best that we can do, and I don't think you're going to be able to change that camera view at all by adjusting things. You know, like I was saying, the only way that I can think of is extending a post out the tip of the nose cone, and it just takes this tube and just moves it back a little bit. But as you saw, it wasn't moving it back far enough, and then it was screwing up the simulations. So that's not working. Terry Wheelock says, I'm going to design a narwhaler. That's cool. Okay. I think that's all the questions that I saw. And I don't think I've helped much today. I think I've caused a lot of confusion. So keep calm, fly rockets. If it's not working, just go out and fly a rocket and come back with a different attitude. So we will be back again next week, July 28th. I should be back in the chair. I'm not planning on going anywhere. Yeah. So until the next time, I'll give you a countdown and we'll be out of here. So 5, 4, 3, 2, 1, go out and launch something.